Trigonometry. So this can you see a triangle on the board? So can you tell me what type of triangle this is? We have studied different types of triangle, right? So which type of triangle is this? Yes, sorry. The right angle triangle with one angle 90 degrees. Perfect. So now we are going to consider right angle triangle. Okay. Triangle ABC with angle B is 90 degree and the C is 30 degree. So now tell me which is the opposite side to angle C? Yes, opposite side to angle C is AB. Perfect. Which is the side opposite to angle C? The side opposite to angle C is AB. Now, which is the side adjacent to angle C? Adjacent side is CB. Perfect. We are going to see different type of triangles on the screen. Okay. Each triangle is a right angle triangle. ABC, PQR, XYZ, and DEF. So now can you tell me, are they similar? Just observe and tell me, are all triangles shown in the figure similar? Yes, they are similar. By which criteria are they similar? Can you tell me that also? Yes. If you observe all the triangles properly, one of the angle is 90 degree, the second acute angle is 30 degree. And then using your angle sum property, we also get the third angle equal, right? It is 60. So every triangle shown over here, that either it is APC, PQR, XYZ or DEF is a 30, 60, 90 triangle. So these triangles are similar by AAA criteria of similarity. Perfect. Now we will write the corresponding ratios. The ratio of corresponding sides of the triangle. Since the triangles are similar, we'll get a ratio for all the sides. Right? So we're going to write that ratio. So what will be the ratio? If we're taking the base AB and the hypotenuse AC, that is going to be equal to the base of the other triangle, that is DE upon DF. Perfect. Next, PQ, that is the base of triangle PQR upon the hypotenuse PR. Then XY upon XZ, as XZ is the hypotenuse. So this ratio which we have taken is on the base upon hypotenuse of all the similar triangles. Okay, why are we looking this? We'll get to know. Why are we taking the ratios of the corresponding sides of the triangle, similar triangles? Now in this picture, you can see we have a triangle ABC with a fixed angle 20 degree, acute angle 20 and angle B is 90. Now I'm reducing the triangle's length. Yes, I want you to observe the ratio AB upon AC, BC upon AC and AB upon BC. Are they changing? No. But now I started to change the angle C. You can observe that when I change the angle C, the ratios are changing. Let's observe once again. If I keep the angle fixed, that is 49 degree, and I'm changing the length, the ratio is not changing. But when I change the angle, you can see the ratio is changing. If I change the length, angle is constant. If I change the angle, the length is not constant, right? So if acute angle is fixed and the ratio of the two sides remain constant, what can we conclude from the previous observation that we have seen? That if acute angle is fixed, that is if I keep a fixed value of angle C, then the ratio is going to be constant. Okay, no matter if you change the size of the triangle, that is the length of the triangle. Okay, the side can be different, but if the angles are same, the ratio is going to remain same. Yes. So such a relation between sides and angle of a triangle comes under the branch of mathematics called trigonometry. Okay. Here you must have seen that we are talking about the ratio and the acute angle of a right angle triangle. So this study comes into the mathematical branch called as trigonometry. What do you mean by trigonometry? Trigonometry is a word that is derived from Greek word trigono, that is triangle, and metron means measure. Major, the study related with the triangles and the measures of the angles and the sides. So this is how we get the word trigonometry. Okay. So now we will be seeing the different ratios. First thing to keep in mind, we are going to apply all the trigonometric ratios to a right angle triangle. As we have seen that if I keep the angle C fixed, okay, so here I have a triangle ABC. The sides can be any, like 10, 5, 9. But if I keep the angle fixed, suppose 60 degree, and you take a triangle with different sides, but the angle C is again 60 degree. My angle C is 60 and your angle C is 60. Then the ratios that come will remain same as we have seen in this stimulation, right? But if the angle is fixed, the ratios are going to remain same no matter if you change the length of the sides of your triangle, right? So same thing we are applying and then we are getting trigonometric ratios. First is sine theta. Here we are considering angle C, so we write it as sine C. If I'm considering angle A, it will be sine A. Okay, so as we are considering sine angle C, we'll be considering it as sine C. So what is your sine C? It's opposite upon hypotenuse. So we'll take the side that is opposite to C upon hypotenuse. Cos C, that is adjacent upon hypotenuse. And tan C, that is opposite upon adjacent. Okay, so we'll write on, and then you have more three. Sine, inverse of sine is cosec, cos inverse is sec theta, tan inverse is cot theta. Okay, so these are the 6 trigonometric ratios that we will be learning in detail. And even the formulas are here. Sine is opposite upon hypotenuse, cos is adjacent upon hypotenuse, tan is opposite upon adjacent, tan is also written as sine upon cos. Now we'll go to the next part, that is trigonometry table. Now this trigonometry table with the values of different angle like angle 30, angle 45, angle 60, angle 90 and angle 0. That is if the angle is of measure 30, what is the value of sine theta? Angle is 45, what is the measure of cos theta? If angle is 60, what is the measure of tan theta and so on. This values we need when we are solving sums related to trigonometry. So we need to remember this table, basic values from 0 to 90 for all the theta, all the trigonometric ratios, sine, cos, tan. If you remember this three, since cosec is inverse of sine, you can just take the inverse of sine theta. Same goes with sec theta and cot theta. So basically sine, cos and tan value we should always remember. Now to remember this value is a bit difficult. So I'll be using you a trick. It will help us to remember this trigonometric table without actually remembering, just using the trick and getting the entire table. So let's go ahead.
Is remembering trigonometric table hard? Let's make it easy. We'll write down the degrees 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Now we'll give this degree numbering like 0 degree with 0, 30 degree with 1, 45 with 2, 60 with 3 and 90 with 4. Then we'll divide the numbering by 4, that is 0 upon 4, 1 upon 4, 2 upon 4, 3 upon 4 and 4 upon 4. Now we'll take square roots of the numbers, that is square root of 0 upon 4, square root of 1 upon 4, and so on till square root of 4 upon 4. Simplifying this, we will get 0 upon anything is 0, so 0. 1 upon square root of 4 will be 1 upon 2. 2 upon 4 will be 1 upon 2. That will be 1 upon square root of 2. Square root of 3 upon 2. And 4 will get cancelled. We will get 1. These values which we have got are the values of sine theta. Now for cos theta, we will write the same values in reverse order. That is, cos 90 will be 0, cos 60 will be 1 upon 2, cos 45 1 upon root 2, cos 30 root 3 upon 2, and cos 0 as 1. Tan theta. Tan theta is sin theta upon cos theta. So we will take the values of sine and cos. Sin 0 is 0 and cos 0 is 1. 0 upon anything is 0. Therefore tan theta will be 0. Sin 30 is 1 upon 2 and cos 30 is root 3 upon 2. So tan 30 will be 1 upon 2 divided by root 3 upon 2. That is 1 into 2 upon root 3 into 2. 2 will get cancelled and we will get 1 upon root 3. Therefore tan 30 is 1 upon root 3. Now sin 45 is 1 upon root 2. Cos 45 is also 1 upon root 2. Dividing both the values, we will get it 1. Root 2 get cancels and we get 1. Tan 45 is 1. Sin 60 is root 3 upon 2. Cos 60 is 1 upon 2. Simplifying this, we get tan 60 as root 3. Sin 90 is 1. Cos 90 is 0. Tan 90 will be 1 upon 0. But denominator is 0. We know denominator can never be 0. So tan 90, that is 1 upon 0, cannot be defined. This value is known as not defined. Tan 90 is not defined. So we'll write it in table form. Tan 0 is 0, tan 30 is 1 upon root 3, tan 45 is 1, tan 60 is root 3, and tan 90 is not defined. Now for cot, we need to write the tan values in reverse order. That is, cot 0 is not defined, cot 30 is root 3, cot 45 is 1, cot 60 is 1 upon root 3, and cot 90 is 0. Cosec is 1 upon sine. Let's see the values. Sin 0 is 0, therefore cosec 0 will be 1 upon 0, which is not defined. Sin 30 is 1 upon 2, therefore cosec 30 will be 2 upon 1, that will be 2. Sin 45 is 1 upon root 2, therefore cosec 45 will be root 2 upon 1, that is root 2. Sin 60 is root 3 upon 2, therefore cosec 60 equal to root 2 upon root 3. Sin 90 is 1, therefore cosec 90 will also be 1. Cosec 0 is not defined, 30 is 2, 45 is root 2, 60 is 2 upon root 3, and 90 is 1. Sec theta will write cosec in reverse order. 90 will be not defined, 60 will be 2, 45 will be root 2, 30 will be 2 upon root 3, and 0 will be 1. So this is how we can write the trigonometry table in easy way. So no need to by heart entire table, just give the numbering 1, 2, 3, 4 to the angles divide them by 4, take them under square root, you will get the values of sine theta. That values we can use to find other trigonometry values. This is remember trigonometry table. Hope you liked it.